Great. So I'd like to welcome everybody to the third panel of the Sydney Science Trail, Climate Science in 2020. Thanks for joining us. I'm Dr. Jenny Newell and I'm Manager of Climate Change Projects at the Australian Museum. And I'll be your host for our time together today. So I'm speaking to you from Darug country, and I'd like to pay respects to the First Peoples of this nation and their custodianship of land, sea and sky, and acknowledge them as the first scientists of these lands. This country always was and always will be Aboriginal land. So just a few housekeeping items before we get started. Students, if you have any questions during our discussion, please just ask your teacher to put the question into the Q&A and we'll try to get to as many as possible at the end. So this session is being recorded, but don't worry, it's just the panelists on camera. And speaking of our panelists, I'd like to welcome Katerina Petru, who's a phytoplankton ecophysiologist at the University of Technology, Sydney. There she is. And she studies microalgae responses to environmental change. I'd also like to welcome Brett Rowling from Central Coast Mob, who is a research chemist at ANSTO, and he cares for the health of soil and water. Finally, I'd like to welcome Brett Summerall, who's the Chief Botanist at the Royal Botanic Gardens and heads up the Research Institute for Ecosystem Resilience. So I'd now like to invite each of you to give us a few minutes on what it is that you do in your work, and then we'll get on to our discussion about climate change. So over to you first, Katerina.
Thanks, Jenny. Before I begin, I'd just like to also acknowledge the Gundungurra people and Darug people of the Blue Mountains region as the traditional custodians and knowledge holders of this land. So as Jenny mentioned, I am a phytoplankton ecophysiologist at the University of Technology, Sydney. And I guess what that actually means, if I just share my screen with you for a moment, is that I study the invisible world of marine microalgae. So what you're seeing in front of you are actually scanning electron micrographs of various marine phytoplankton species, magnified at several thousand times. And these little guys are incredibly important for our ecosystem and our globe. They produce 50% of the oxygen in our atmosphere. And they are the base of the marine food web, supporting every organism within the ocean. My particular area of research is looking at how various climate change impacts like ocean acidification or ocean warming influence their physiology and ecology. My studies take me to Antarctica for various research projects, where I investigate how Antarctic phytoplankton and sea ice microalgae are responding to these changes. So here you can see some of the ways in which we get there, the boats we take, some of the wildlife we get to see, and then there's some sampling from both students and myself and various other members of my research group when we're down there. So this is some of the laboratories we use down there. There's one just in a container that's makeshift on the edge of the sea ice there. And then there's also the internal laboratory space where we do a lot of our algal incubations. And we get to see some of these little critters when we're down there. Of course, the most important being the microalgae in the bottom left-hand corner, but the others are a delight as well. My work also takes me to the Great Barrier Reef, where microalgae that live within corals as symbionts are under threat from climate change as well. So I look at how ocean warming, particularly in coral bleaching responses, and how these microalgae are affected at a physiological level. So trying to understand what's actually driving the bleaching response. So a lot of my work is done looking at, through a microscope, but also looking at those individual cells. That's it from me.
Rina, do you want to just tell us briefly about how you got into this wonderful area of research?
Yeah, I guess I had a little bit of an unconventional pathway. So I left school. I was actually out of school for several years before going to university. So I entered university as a mature age student. And I've always had a love of nature and the environment. And I really wanted to see what I could do to help preserve and create a more sustainable environment and look after nature. So I went to university to study environmental science, and then through that, my first look down a microscope at phytoplankton, I fell in love, and that's the sort of the area I ended up pursuing through my doctoral studies.
Fantastic. I'm not surprised you fell in love. They're amazing and so important. Yeah. My goodness. Thank you very much. I think we all share that great love of nature and the desire to care for it. So that's what brings us all together here today. Over to you, Brett Rowling.
Rightio. Well, okay, that's what I'm going to run with here, isn't it? It's a bit like a Where's Wally slide, but anyway, that's all right. So my peoples are from the Central Coast. I'm a descendant of Bungaree and Matora. This is Bungaree, this is Matora. Bungaree visited everywhere around the country because he went with a chap called Matthew Flinders and enabled him to complete the first circumnavigation. So we're already on the national level. My work is with ANSTO, which is the Australian Nuclear Science and Technology Organisation, and we're the country's only nuclear facility. And we have 3 campuses. One that's based down in Melbourne, that's the synchrotron, and that's on Kulin country. You've got Lucas Heights, which is where I am, which is Dharawal country. And then you've got the cyclotron, which is in the middle of Sydney, which is now on Eora country. And these names of nations all loosely translate as, well, Kulin for Victoria means loosely man, Eora is people, and Dharawal is cabbage tree. And these words come about because they were really the common words that were heard from the first Europeans, from us for the Europeans to first hear us. So the works that I'm involved with is air, water and soil sampling from right around the country. There's a photo over here looking at a place called Kulnara, which is, for me, well, you know that as Peats Ridge Springs, but Kulnara means for us into the clouds. It's a spiritual site. So if you like, you know, first scientists, engineers, it still continues. And then there's also stuffs like where we have elements where we tie in with cultural awareness and recording sites and so on. So what we've got here is, actually on my own country, is over at Manly, was to look at some hand stencils. And what we've done, we couldn't date them, but what we could do was use a little drone which goes around and could then record the site. And if you like, it's a digital preservation, because a lot of these sites now, they're, if you like, gradually diminishing back back to original stone. And there's also this little lady here is Fran Bodkin. She's from Dharawal. I think this is quite appropriate because we're dealing with the Botanic Garden. She also has one, a rival, I suppose, up at Mount Annan. And she dabbles in looking at the science of how plants work and so on, but from an Indigenous perspective and how we used to use them. So what I'm continually showing here is our continual connection to country, which in my language, Manio Umilyan Guri, is exactly what that phrase means. And really to the beginning of how all this came about for going into science was I loved science and maths at school. Originally, I actually started out doing science teaching because I thought you had to be very intelligent to walk around in a lab with a beaker. But as it went along through my university studies, I'd had some time with a year in industry at ANSTO, and the rest, as they say, is history, because once I came here, there's a lot of things that go on. I mean, what I've shown you here are some of the really more interesting parts, because, you know, most of my time is actually in a lab, but, you know, who wants to show a photo of a gloomy building? Let's get out and about and enjoy some time. So there you go. Thank you.
Fantastic. Thanks so much, Brett. It was wonderful. Wonderful to meet you and your work, your important continuing work there. So thank you very much for that. And let's head over to Brett Summerall.
Thanks, Jenny. Hopefully that's working. So my name's Brett Summerall, and I'm the Chief Botanist at the Botanic Gardens, based at Sydney, but we have 3 sites, so on 3 different countries. I'm currently on Dharawal country out past Camden, where the Botanic Garden at Mount Annan is, but we also have gardens at Botanic Gardens in Sydney, of course, and at the up in the Blue Mountains at the Blue Mountains Botanic Gardens. We just don't work in the Blue Mountains. We work all across the state and the country, and internationally for that matter. We, in the top right hand of the slide I'm showing, that's in our herbarium collection, which, if you like, is like a plant collection, a museum collection for plants. Lots of dried specimens. Just there filming some story with Sam Neill a while ago about some of the Banks and Solander collections, which were collected with the voyage of James Cook, Captain Cook, in 1770, and also in that collection is some of the specimens that were collected on that trip that Brett Dowling mentioned, with Flinders, collected by the botanist on that trip, Robert Brown. So there's 1.4 million specimens there, but we're also out in the country collecting plants for our seed collection to preserve and protect plants, particularly against things like climate change and bushfires. And my particular interest is in working on plant diseases, on sort of, if you like, the plant equivalent of COVID, trying to come up with strategies to protect the plants, to help them survive into the future, and working out what these sorts of organisms, mainly fungi in my particular case, what they do and how they impact plants. And so up on the top left hand of the screen is collecting some soil samples from the Wollamai Pine site up in Wollamai National Park, a really treasured, important plant community discovered in 1994, dating back to the Jurassic period, and also collecting and trying to keep that disease out in the south coast in the bottom right-hand corner. So lots of work that our scientists do, over 50 or 60 scientists at the Botanic Gardens working in all areas of plant ecology and plant science. Thanks, Jenny.
Wonderful. Thank you so much, Brett. And thanks to all of you for helping us see how important it is to understand our world in more detail so we can all care for it more effectively. So thank you very much. Now I'd like to pass over to, let's go to Brett Summerall for our first question, which is, what is climate and what is climate change?
So it's an interesting question in terms of what is climate, what is weather. So climate is the sorts of weather patterns that we observe and see over longer periods of time. So generally when we're talking about climate, we're talking about a weather pattern in a particular area averaged over a period of time, usually about 3 decades, 30 years. So we're talking about how changes occur over that long period of time. Weather, on the other hand, is much more variable, and you can see weather changes on a day-to-day basis. So, we talk about the climate of Darwin and the climate of Hobart being very different. Darwin is hot, humid and sticky. Hobart's cool. But on a particular day, the weather patterns can mean that Hobart may in fact actually be hotter than the temperature in Darwin. So when we talk about climate, we're talking about long-term weather patterns. And when we talk about climate change, we're talking about how those long-term patterns are changing over those periods of time. So with climate change, we're now at the point where we're seeing the temperature patterns on an average of 1.1 degree higher than they were in the pre-industrial period. So we're seeing a warming of the planet, and associated with that warming of the planet, we're seeing changes in the way in which we receive and get rainfall. We're seeing changes in the extreme nature of temperatures, and we're seeing associated changes in organisms, in activities, in severe weather events associated with those changes. And those changes in the climate are mainly brought about by the impact of humans, by the use of fossil fuels and the like, and the increased production of greenhouse gases, carbon dioxide, methane, and other sorts of greenhouse gases, producing this, if you like, this greenhouse layer in the atmosphere that traps the temperature in and results in an overall increase in the temperature patterns and in the climate over that period of time.
Wonderful. Thank you very much, Brett. So, Katerina, can you tell us, people often say, well, there's been climate changes in the past, there's been fluctuations in the past. What's different now?
Yeah, it's an important aspect to understanding what we mean by climate change and why it's particularly a climate emergency for us at the moment. It was so in line with what Brett was mentioning, if I can just take you, this is something I just wanted to share with you. This is actually a temperature gradient as a graphic of the last 150 odd years. So from 1850 to I think 2017, and this is just showing temperature change in colour. So the 1.35 degrees increase we've seen as a global average in the last 160 odd years. But when we talk about climate change, it's all a matter of scale. And when we talk scale, we're talking time scales. So this graphic here actually shows us all the way back to 500 million years ago. And climate has changed on our planet quite substantially. This is a temperature graph. So the lines we're looking at actually show temperature and how it's altered through time. And those fluctuations closely match CO2 in our atmosphere. So if we go right back to several 100 million years ago, and I've put dinosaurs up there so that people can sort of think of what the world looked like, perhaps, and understand what was going on. We had very high CO2 in our atmosphere and very warm temperatures compared to today, up to 14 degrees higher on average for the planet. And it looked very different. The Triassic, Jurassic period, the world was a very different place. After the extinction, the mass extinction of the dinosaurs, we saw the Earth started to cool, or the planet started to cool substantially. That's that green part here, around 65 million years ago. And then through the Eocene and down, and CO2 in our atmosphere also declined. So we started lowering the temperature and CO2 in our atmosphere, and we saw the Earth changing quite substantially again, habitats arising that were quite different, the rise of mammals. And then as we move further through time to sort of 3 million years ago, the end of the Pliocene, we see the rise of the first humans on the planet. And this was actually the last time our planet had atmospheric CO2 concentrations of around 300 or 400, which is what we're currently at today. Interestingly, back in that time, temperatures were up 2 to 3 degrees warmer than they are now. And habitats looked very different. Not only that, the temperature increase or difference in the Arctic areas was up to 10 degrees warmer. And that meant sea levels were 15 to 25 meters higher than they are today. So much of the land we know today was submerged underwater, and habitats were quite variable. So where there might be deserts today, there could have been forests and vice versa. So we have seen temperatures similar in the past, but since then, over 1 million years and to present, temperature and CO2 have been relatively stable. And you can see here through the rise of Homo sapiens and then into modern time, temperatures have been fairly consistent, as has CO2 in our atmosphere, between 180 to 280 parts per million. And we can have a look at those little wiggles at the bottom, and they each represent 100,000 year cycles of ice ages that we seem to have periodically. And then as you come into modern age here, we have right at the end, we have sort of ancient Greece, 2,000 years ago, and modern times. And you can see right at the edge of the graph, there's that little stick that increases that shows predictions for 2050 and the end of this century. So when we talk about temperature and climate change, we can really talk about it with perspective to just that last 800,000 years. So here we can see these cycles, and instead of temperature, we're actually seeing CO2 because they parallel each other quite well. And these changes in temperature every 100,000 years are what are termed Milankovitch cycles, and they're related to how the Earth travels around the sun. So sometimes every 100,000 years, it changes from a more circular orbit to a more elliptical orbit, and that alters the overall temperature of the Earth. So what's really interesting is you can see this deviation from our CO2 levels since 1950s onwards. And as of July, the latest average atmospheric concentrations from Mauna Loa, which is our main research site for detecting that in Hawaii, is 414 parts per million. And ultimately, the biggest difference, while it's been variable, is the rate. So what we're seeing is an incredibly rapid rate of change. In the past, it was over several millions or thousands and millions of years, so things could evolve and adapt. We're seeing massive changes occurring within 150 years. And I'll just...
Thanks very much. Thanks, Katerina. Yes, it's the rate of change, isn't it? That's the crucial problem. It's such a fast change. So let's think a bit about our future world. And what will our lives look like in 20 years, say, if we keep going with emitting as many greenhouse gases as we are now? And the flip side of that, what will our lives look like if we make big changes now? So I might pass over to Brett Rowling for this one to start.
Sounds frightening.
Oh, yeah.
It does in a way. Well, as an Indigenous person, we always look at things in the really big picture. And actually what I'm going to do is I'm going to segue a little bit out of what both Brett and Katarina have already put there, but put an Indigenous perspective, because you see these major changes. For example, and I think a lot of places, what people want to see is consistency. Things don't change, but in reality, there are quite major changes that have occurred. For example, if you stood in front of the Opera House today and you look at the bridge and look down the harbour, you think, wow, that's beautiful, fantastic. But 6,000 years ago, you would have looked to South Head, and in our language, that's Tarolbai. That's an island. And at 20,000 years there or thereabouts, you had another 8 kilometres of land. So, and we know that these straight out from the soil cores and so on, we can date them and prove them through science, but we know through the language and through the stories, we can tell you that this occurred. They're the dates, you know, because women did the math, not the men, but we can go into detail on why that is, you know, but we can see these major changes there because we had people out to the east. What happened to them? You know, so there's those sort of changes that happen. If you then go and look at, you know, there's an element here, people might look and say, I'm pro big business and, or maybe a skeptic. But if you go back and you look in time, which is what we're loosely talking here is the Industrial Revolution, we had that too, because you had, from our time, we were annealing quartz and taking sherds of that, making it harder, and it was a longer spear tip. Your next to jump to that comes later in more recent time is, of course, the coal industry. Now, the coal industry really takes off originally in Germany. And so what you have there is, you know, initially they're all excited because now I've got a new fuel source, but very quickly it becomes this environmental side because you had waste waters, you had compounds, you had coal tars. What do you do with that? And the environmentalists were worried about that being in their water and what they were drinking. So what they did, what the researchers did, was to collect these compounds, and that's really given us a lot of the drugs of what is today. Paracetamol is one of the biggest ones that came out of the coal industry at that time. Then if you jump the next, you have the steel industry. Even during the time, if you look at the way the steel industry works, is originally everything was thrown in big lumps, you know, big lump of iron ore, big lumps of coal. As it's gone along, you've become more like fuel injection. So your production becomes a lot more efficient as it goes along. And one of the things that I think people don't realise is how much of, say, the gases and so on that are produced are recovered. Now, in the case of BlueScope Steel, they recover approximately 99% from their coking technology. And most of those gases are exotic gases. One of those is oxygen, and that's most of the hospitals in New South Wales, nearly everything in Queensland, and and a fraction of the hospitals in Melbourne receive high purity oxygen from coal. The remainder comes from the other major steel factory, which is over in Whyalla. Another exotic gas that you get is hydrogen, because of course now you're looking towards the renewables, right? So you're talking solar cells. And this is where I start to throw out things like, well, here's the question. If you're now building something, because you look at the solar cell thing, it's beautiful, clean, no emission, etc. What you've got to think about is when you're producing it, what does it produce? Are there any emissions? Are there any toxins? And also the other end of it, which is when you're disposing of it. This is what we call cradle to the grave. Now, if you jump, there's two things that are going here. One, of course, is solar cells, which is the big one. And the other one is, say, hydrogen as a hydrogen fuel cell. You burn hydrogen in inverted commas. What do you produce? And your emission is water. The question then is water is water also a greenhouse gas? What I'm doing here is I'm not necessarily answering the question, but what I'm really going for is to make you think. If you're taking something on, what are the end results? What are you actually after getting at the other end? Because you can see what I've just given you is a nice little history lesson right through from Indigenous time, through the Industrial Revolution to the end of where you're at now. There's a lot of similarities. And so really the crux of what I keep coming back to with this was my phrase, which is Manu Milyunguri in my language, which is still taking care of country. And your main things when you're looking at these, what do I actually need? How much do I really need? And it's not going on and going silly with, you know, any particular building. So that's what I would add.
Thanks very much, Brett.
I know that hasn't quite answered the question, but the idea is just to get people to think.
That's good. Yep, absolutely. And I think, yeah, there's lots of great research that shows how effective solar panels and hydrogen and wind powers are, and that the amount of material and waste required for producing those is really, really minimal compared to the overall clean energy that you're able to produce over the life of those energy sources. So that's great, and that there's been so much great development and research and fantastic results done, particularly here in Australia. So yeah, you're right. It's a really important thing to look at all those aspects for whatever type of energy we use and whatever transport we use as well. But really thinking through how we care for country best. Yeah, thanks very much. Fantastic. How about we go to Brett Summerall for some thoughts on our future world and how it's likely to look in 20 years if we keep going with emitting greenhouse gases from sort of looking at the terrestrial realm. And we'll go to Katerina afterwards to look at the marine realm. Thanks.
Yeah, thanks, Jenny. If we look at the changes in the climate and the impacts it's having on terrestrial ecosystems, and obviously my focus is looking at what are the impacts that the changes that we're seeing in the climate are having on plants. Katerina mentioned before that these changes are happening extraordinarily quickly, and of course that's much faster than the ability of any sort of organism to evolve or to adapt to those sorts of changes. So one of the difficulties that we have in looking at how different types of creatures can adapt and protect themselves or move to a different area is their capacity to do so. And so I think from our perspective, looking at it from a plant point of view, we'll see that, some of those particularly sensitive communities are things like rainforests, things like our ecosystems in alpine areas. These are dependent on a very stable environment and have adapted over very, very many long periods of time, particularly our rainforests are remnants from way back in Gondwanan times. And so their ability to change and their ability to move to new areas to colonize is very, very limited, and the timescales that we talk there are very changed. So they're very much under threat because of reduced amounts of rainfall and higher temperatures in those areas. Our alpine areas, they are mostly adapted to growing in a very narrow range of temperature conditions. And so, you could argue that as the temperature's warmer, some of those organisms will start to move up and up those alpine gradients. But of course, there becomes a point where there's no longer any more alpine gradient to move up, and they run out of a space to move to. So we're very concerned about the long-term stability of those sorts of ecosystems. And of course, the other aspect of the changes in the climatic condition are of course drought and the presence of bushfires. So we're seeing very long extended periods of drought, and that's having a dramatic and significant and long-term impact on many vegetation communities. Over this last period of drought, we saw a lot of ecosystems die out and be affected. And of course, then we had the bushfires that we experienced over the summer period last year that had a dramatic and devastating impact on plants and of course on animals. And of course, if you don't have those plant communities stable and surviving, then all of the creatures that depend on those plants are unable to support. So there's a whole range of changes that we're likely to see in terms of the changes in climate. And not every place and not every location will be adversely affected. There will be places which may well get more rainfall, or which the weather conditions are more favourable for growing agriculture or for forests or whatever. So there will be variability in those changes and the impacts that we'll see in our terrestrial environment. But we're very concerned about that the impacts will be quite dramatic on the natural ecosystem and on their long-term survival if we don't make changes. If we make changes, then we can work with those environments. We can look at different options to making sure that we can restore as many environments as possible. Obviously, if we go about planting more trees and trying to start to capture some of that carbon in the atmosphere and improve those conditions, then that has a long-term beneficial impact on improving things so that the future environment has a greater chance of being much more healthy and happy.
Absolutely. Thank you very much, Brad. So Katerina, do you want to reflect on those questions around the marine environment? Thanks.
Yeah, absolutely. A lot of the marine environment parallels the terrestrial environment, obviously. I mean, our planet is 70% ocean. So if business as usual, we do nothing to reduce greenhouse gas emissions, in the next 20 to 30 years, we're looking at our globe reaching 3 degrees warming by the end of the century rather than the 1.5 we're hoping to achieve by introducing reductions. And that really will result in very early on losing the polar ice sheet. And so Greenland and the Arctic would become an ice-free zone in summer. That would obviously have implications for sea level rise when we look at Greenland, the Greenland ice sheet melting. Habitats shifting. So currently we've actually already seen species migrations up to 400 kilometres away from their original areas simply to chase those temperature gradients they're interested in. And along with that comes loss of biodiversity, so mass extinctions. If we do nothing, we're starting to lose species that can't adapt, much like alpine species have a limited range to go on terrestrial environments. So too in the marine environment, whether they're polar species or tropical species. Species take a long time to evolve and adapt, and this rapid change just simply means we're not giving them enough time to cope. So we're likely to see increased events of coral bleaching. We've already seen increasing frequencies in the last 5 years with 3 major events across the globe, hitting the Great Barrier Reef quite substantially. And of course, with more and more frequency of these events, there's less chance for recovery and resilience. So I think storm events, all these other things, a lot of displaced people. We're going to lose island nations from sea level rise. We need to find places, low-lying countries like Bangladesh, the Netherlands, some coastal areas. We need to find places, and with increased climate refugees, there's obviously other political and economic issues involved with that. So I think the biggest aspect of not changing is we're destabilizing our ecosystems that provide really important services for us. If we do change, however, and we make really drastic changes now, we are still going to see an increase in temperature and some loss because there's a lag phase. Temperatures will continue to rise to match CO2 emissions. CO2 emissions will continue for a while. But if we can stabilize them early enough, really what we're looking for is the ability to avoid ecosystem collapse and really give the organisms chance to recover and adapt and survive. So it's imperative we change that, but think of the really good aspects of changing it as well. I mean, just the simple act of changing to electric transport, so cars and transportation. You could live in a city with clean air, low noise pollution. It would be just such a wonderful thing for all of us to experience, and that's just one little aspect of it. But I think acting quickly, it works here for the benefit of all of us. It really does, including the environment.
Absolutely. Thank you so much, Katerina. And that really leads into our next question, which is really what measures can be taken in Australia to reduce runaway climate change? And you've spoken there about electric cars. I think there's been a 3-fold increase in electric cars sold in Australia over the last year, and it's really, it's going to ramp up. And if there's more support from the infrastructure, that'll be even quicker. I think there's a reduction in price on electric cars because they're being picked up so rapidly around the world, and more infrastructure for charging points, and you can get about 400 kilometres on a charge these days with electric cars. So they're coming along leaps and bounds. So it's going to make a huge difference, as you say, to the quality of life, the air we breathe. And whenever we speak to GPs around here, as we're doing our research about impacts of climate change, we often hear about the impacts of fossil fuel emissions on air quality and what impact that has on people's hearts and lungs, because they're the areas that get really severely impacted, and also the impacts of heat. So if you're burning coal and natural gas, then you're increasing the whole temperature of the globe, and then that's increasing the chance of having heat waves as well. And so that's, in fact, heat waves are more they're more fatal for us than all other natural disasters combined. And so there was, in fact, more people died before the bushfires this past year because of heat waves before the bushfires than in the fires themselves. So thanks for those reflections. So other measures that can be taken in Australia to reduce runaway climate change. Can I head over to, let's go to Brett Rowling again.
Okay. Okay. More examples or more? I suppose in a sense, look, one thing I suppose that comes out of all this is not to put, I suppose, all your eggs in one basket on one particular technology type, and even what comes out of it. And part of that's because there's an element of when I get a bit alarmed when people say, well, you need to rush and solve this problem. I suppose in a way I'm going back to what I really just said before, but there's an element of you need to be very aware of what affects what. You know, if you put in, say, for example, a set of solar panels, what is their what do they reflect energy-wise? What do they also then retain themselves energy-wise? And I'm talking temperature there too, simply because of what their colour is, or rather their shade, because usually they're a black or something like that. So, but what you're seeing as you go along with that is the fact that because you're starting to see some of these issues that come along, then you start to evolve them and improve them further simply because of the issues that start to come along. There you go.
Thanks very much. That's great. How about you, Brett Summerall? Have you got some ideas about other things that Australia can be doing, you know, in all sorts of realms, actually, to be reducing runaway climate change? And that can be thinking about restoration of wetlands and forests and all these other very important things that we need to do.
Yeah, so I suppose part of that process of mitigation and also protection is often tied up to, you know, the opportunities we have to plant more trees in the ground to produce, you know, to restore some of those really critical ecosystems, to get a greater tree cover and tree canopy across lots of areas that have been cleared, often for marginal reasons. So the opportunities that we have in terms of planting, restoring ecosystems, and even in urban communities, the impacts that you have in terms of planting trees, getting a canopy up there, in terms of protecting houses, protecting communities from the harsh impacts of high temperatures, and also for mitigating the impacts of quite a lot of those sorts of climatic changes is quite substantial. So there are a lot of benefits that can be done just from the simple act of planting a tree, which is something that, you know, individuals can do, something that communities can do, and it's something that can be led by some of the government programs that are really critical in order to get these things happening at a massive scale, so that it does actually start to have an impact. Of course, it does take substantial time for these sorts of programs to have a huge impact, but the benefit of trees is not just in terms of climate mitigation. It is also, we know that people have better mental health outcomes, lower crime rates, all of these sorts of benefits, and greater urban biodiversity, which I think is a fantastic thing to encourage as well. So there's multiple benefits in that sort of simple process that goes back many thousands of years, but I think is really something that we can all get involved in.
Fantastic. Thanks, Brett. Katerina, do you have any other reflections on this?
Yeah, I think in addition to these sorts of solutions, which I think are critical, I mean, replanting forests and planting more green, even in cityscapes, is going to be really important for our well-being. But I also think in Australia's case, we really could lead by example. We are a very fortunate nation. We could make very good investment decisions towards investing in renewable technologies, advancing those aspects of it so that other nations can follow and it finds a new way of doing things. I think divesting away from or taking away the dependency on coal and gas earlier rather than when it's become critical across the world would be a very clever thing to do. But I really think Australia has an opportunity to lead by example. And I think the biggest aspect to this is it's not an Australian problem, it's a global problem. And if there's anything good to take away from COVID, we've seen that at a global scale, the world can change very quickly, the way we do things. So I think if we can garner impetus from that change and say, well, now we've got to re-stimulate the economy, let's look at how we're going to do that. Let's make really good choices as to what we're going to put that money into. And is it a good sustainable option for the country and for the globe and life in general?
Absolutely. Thank you. Yes, extremely good points. So let's think a little bit about what practical advice we might be able to give our audience. And we will check in a minute whether there's been any questions come in, but we might just see if, unless there's anything that's come in, Tori, we might just continue on with talking about what sort of practical advice, what sort of things people can do themselves. And let's head over to hear from Katerina.
Yeah, well, I think there's a lot we can do as individuals and communities, and I think re-greening environments is really key and quite simple, whether that's at a community or a local level. And also things like consumption. One of our biggest problems is overconsumption. So whether that's getting a little bit on top of reuse, recycle and reduce, those sorts of key messages are really important. Reducing beef intake by 2/3, if everyone just did that, we could save a lot in greenhouse gas emissions. And also just through the land use. I mean, beef is incredibly energy expensive to produce. But I think more than anything else, be engaged. So as an individual, be engaged in local action groups, be engaged in the science, be up to date and informed. So make sure that you're making evidence-based decisions, and understanding is really key, because every decision you make eventually has an outcome or an impact. And that sort of links back to, I think Brett Rowling was saying, this idea of cause and effect or impact of events. So I think there's a lot that can be done at the local and individual level. So stay positive and be active. Yeah.
Thank you. Really good points. Thank you. I'll hardly applaud those ones. Brett, over to you. Brett Rowling. Let's go to Brett Rowling next.
Oh, no, we have to be very careful with Brett.
Trying to get both of you talking at once.
That's all right. I'd hit it from a slightly different angle with some of this, in a way, because what I do is, like, you're in a very, I love the idea of being a world leader as Australia. It's Australian made, so of course it's going to be the best. Now, an example here is looking at the environment for the solutions, and in fact, that's really where all these prehistories all began. You know, the oil industry, in a way, put a figure on it, I think it's something like a $3 trillion industry. So you can see the sort of uphill you've got, in a way, dealing. But it's a very easy set to work with. However, before that, it all came from nature. And an example of that was when the Europeans first showed up here, they knew that the honey that we had, which is jelly honey from the states north and up into Queensland, was really, really good. It was traded. We loved it. We thought it was great. The Europeans thought the same thing too. Very tasty. Better than what they had at home. Of course, it was Australian made. To extract it was very difficult, and they didn't like us as black fellas because we simply wouldn't tell them how to do it. But the process was so difficult, we weren't going to. And so they solved that problem. They brought in the European bee. Now, it's gone full circle. The wheel is round, right? So today, there's a whole load of research. The part that gets a little bit on my goat is the fact it's white fellas doing it when it should be us. But anyway, what they've found is it's antibacterial properties. It's a bit like Dettol. It's a bit like a Band-Aid. It's also, there's a few small compounds that have come out of it, which they're actually using because the golden staph is now antibiotic resistant. So we now extract that compound and it now treats the golden staph infections. So what you've got here is already in nature the possibility of being able to actually be doing things that if you, you love to use the word sustainable, but it's already here, you know. And again, it still comes back to the use of looking back to nature for the solution. And you see that quite often in engineering, you know. For example, I mean, tunneling's a great one because they see the teredo worm, which used to go through and bore holes in ships and bore holes in timbers. But as it went through, the mollusk part should be crushed. Its head's hard, but the back end is so soft. But what it does is it lines the tunnel. So it's a factor when you do tunnelling, you cut the hole, you put your circle in, you keep going forward. So there's your little mollusk. So it's all those sorts of things, and looking at nature for the solution, simply because it's often already, it's been here for thousands, millions of years, depending on the situation. There's the answer. You know, why you're trying to reinvent things. So it's just a different way of looking at it anyway. There you go. That might open the floor to something.
Thank you. That's great. No, it's really important to being really open to learning from nature. That's certainly, getting solutions from nature is such an important thing for us to do. We need to be listening and observing and watching much more closely than we've tended to in the past, or learn from all the First Nations people who've been doing that for so many tens and tens of thousands.
Correct, because our science is observation and experience. It's practical science. Okay. When you come to European science, it is data and analysis. That is theoretical. You put the two together, it's great. But to me, life is practical. So it's spot on. That's how it should be. Anyway, right, Brett, your turn.
Okay, another Brett.
Yeah, so you know, what can be done? I am quite inspired by the way in which young people are being active and very, very involved in looking at the problem of climate change and you know, being very active in trying to stimulate our government, push our governments of all natures and all sorts to be more proactive in terms of their response to climate change. So it's a little bit disingenuous, I suppose, for a person of my generation, which is part of the problem, telling young people what to do when they're very active and they're very, you know, very inspiring. You know, I was fortunate enough to be at the Domain when one of the big demonstrations last year, and it's fantastic to be in that environment. There are so many things that can be done. Reduce what we consume, recycle what we use is really good, really very important. Look at options, stimulate your school, stimulate your community, stimulate your parents to look at options which may change the way in which they use energy to be a little bit more sustainable. Avoid food waste and the like, because it's really, our food production is really critical to our future, and we waste far too much of it. 30% or something of our food ends back up in a compost pile if we're lucky, or just into landfill. So these are all things that can be do. Encourage your school to plant gardens, to have a bush tucker garden, to have a veggie garden, to compost bins, ways in which they can reduce the refuse and the garbage that they produce, so that we are all working in a more sustainable way. Australia produces a very small proportion of the carbon into the air globally, but we are very, very influential in the way in which we do things, the way in which we hopefully can improve the way we interact with nature and our First Nations communities. So I think there are all sorts of opportunities in that space for us to do better and to improve the way in which we interact with nature in order to be able to improve the climate and how we're impacting upon it.
Fabulous, thank you. Extremely good points. And I think it's really inspiring that there's so much that young people can do through their schools. I think, you know, just making a few inquiries. I've done this recently. It's with my sons. It's really easy, actually, it turns out, to get solar panels on your school. It's just a few people need to work together on it, but it's the sort of thing that can be achieved without undue difficulty, because there's lots of organisations out there to support schools to do that. So a bit of research online and so on, and you can really make waves, really make a big difference, and save your school a lot of money as well. So that's another great thing. We've got lots of good ideas about what people can do on the Australian Museum's website, and we'll be adding to those over coming weeks and months. And we've got a wonderful exhibition called Capturing Climate Change, which is an online photographic exhibition, which we really encourage you to look up and add your own images too of the things that you see around you that are really reflecting climate change, and also the solutions that you can see and the solutions that you're taking forward. So do share your images and your captions on capturing climate change. I'm now going to, and also when the museum reopens at the end of October, do come along and see our new climate change exhibition, which will really be focusing on impacts and solutions to climate change in Australia and the Pacific. So we'll now pass over to Tori for a question. Thanks, Tori.
Hi, everyone. I think, Brett, you kind of ended on a great end for the question I've got here. Is we've talked about what students can do at school, but what about at home? If I've got a parent or a grandparent who perhaps isn't as quiet on board as I am, how can I get them on board with this? How can I help them make change in our own household?
I think the money is always the best driver in these sort of circumstances, and look to promote the opportunities that many of these things are. In the long run, some of them may involve an investment up front, but in the long run, we're talking about activities and issues that are likely to save a household money. So we do waste a lot. We waste a lot of energy. We use cars far more than we need to, and we waste a lot of food and other sorts of products, and we buy things really quite often that we don't actually need. So the bottom line, the financial bottom line often works really well, when you're talking to parents and grandparents even. So get out there, do it. Yes.
It's a great idea. Fantastic. Okay, so I think unless anyone else has any comments, anyone of the panel want to say anything else, what we'll do is just let you know that tomorrow there's another panel discussion, and it's Women and STEM and their journey into science, and that's also at 11, so you can register for that on the Dart page. So just behooves me now to say thank you very much, everybody. Thank you so much to all our wonderful panelists and to all of you out there listening to us. And we hope you've learned something and that you feel inspired to join in and help us in climate action and for caring for country. So all the best to everyone, and thanks very much to our wonderful panelists.
Thank you.
Thank you.
Thank you.